Okay guys, today we're going to hack the video chip on the Coco computer. So here's our screen. And here is pin 28, the Y signal coming out of the VDG chip. So what we're seeing here is a horizontal blanking pulse, black level, that's the border on the side of the Coco screen. Here we have our cursor going from bright to dark. So this is actually inverted. This is the brightest we can be. This is the green level of the video. This is the word Microsoft and OK. So we're starting at the left side of the screen, we scan to the right. So we don't have any writing here. Now this writing is in black, so we see it there. Here's the other black border and the last of the, we'll clean this up a little bit. Another horizontal sync. So I've got the time base set for 10 microseconds right there. So that means each one of these little squares is worth 10 microseconds. So we can see here is the H-sync pulse and it's 1.2. So 1.2 times 10, that's our 12 microsecond pulse. So if we check how long the whole period is, it's 10, 20, 30, 40, 50, 64. So it's 64, technically it's 63 point something. So the problem with this video is we have a lot of wasted space here and a lot of wasted space there. So we're going to adjust, get rid of the ghost. Here I did a poke to remove the black border on the screen. So let's turn up our intensity. So these guys didn't change, but we see that we have this available in the screen. Here's our word Microsoft. And we have the extra space. So what we're going to do is we're going to try and capture that space and use it. So here's our data sheet on the chip. We can see the black border I was talking about. And there's our normal field that we get to use. This is the chip itself. Now the pins that concern us are the Y signal, which we saw in the scope, the field sync, and the horizontal sync. Now, this guy here occurs right here. So we're going to pull this signal off and look at it on a logic analyzer and see what we can do with it. Okay, now we're going to do something different. Instead of looking at the waveforms on the oscilloscope, we're going to use a logic analyzer. So I hooked up to the two pins, the HS and the FS of the video chip. Here we have our horizontal syncs, there's a lot of them, and here we have our field sync, which the Coco takes at the end when it's finished drawing a screen. We can check the time base of that, which is 16.67. Which is 1/60th of a second, giving us just about 60 Hertz. That's where that number comes from. And now we're going to look, we're going to expand our view, and we see the horizontal sync pulses generated by the video chip. Now it doesn't have a complete, it's not a complete composite signal, this is just H-sync pulses. And during the FS period, there's 32 pulses. That's because after it's finished drawing its screen, it does 26 for the border, 6 during the retrace, and there's our 32. Now we want to get back up here to start getting the information for the screen. So we're going to have to add the 26, the 6, the 13 that's wasted in the vertical blanking, and our border 25. So what we need is a counter. So we're going to start counting our signal right here. We're going to count 70 cycles of the horizontal, and then we'll be placed in the right position to start doing our own video. And if we look back at our chart, the horizontal sync actually starts over here before the border. So we're going to count 70 and we're going to be right here. So next time we're going to make a counter and see if we can generate our own VGA display.